Welcome, Math Dragons. This is part of your homework this weekend. I've got page 21 and page 22 here. 21 is this foldable here with math properties. Associative property, identity, commutative, and distributive. And then over here on 22, we're going to dive into more about the addition properties and the multiplication properties. Take a moment and pause the video after I zoom in on this so you can write down all these components on 22. So pause the video now, write down all these components on page 22. All right, let's continue with the foldable. So back on page 21, we're going to look at the four properties. Open up the pamphlet and look at the commutative property here. Make sure you have a writing utensil ready, and we're going to begin. You can swap numbers around and still get the same answer. When you, and this only applies in two operations, think about which two operations this might be. When you add or multiply. Interchangeable in order. So, if you might recall, I did say commutative property is the swapping. So there's the key word there, swap. So an illustration of something like that would be, say, let's say we have something like 4 times 2. And if we were to illustrate that using a pictorial representation, we could make an array that is 4 in a column, and we have maybe 2 columns. But that array would contain the exact same amount if I had 2 rows and 4 columns. 1, 2, 3, 4. Either way, you have 8 of the shape. So it doesn't matter which way you set up the array. That is the commutative property. Another example of the commutative property is addition. Something simple like 6 plus 3. So you could have 6 circles and 3 x's is the exact same thing as having 3 x's and 6 circles. Looks like a game of tic-tac-toe. Okay. So that is a commutative property, swapping. Distributive property we have gone over extensively. That is the area model that we have talked about for weeks now. So, a characteristic of numbers that allows you to, keyword here is multiply, a group of numbers and get the same answer you would get if you multiplied each member of the group and then combined the answers. What does that mean? Let's look at an example. We could have 4 times the quantity of 3 plus 5. What does that look like? You could have 4 blocks. Making like long rows here to illustrate this purpose. And each block would be worth a total of 8, whereas 3 is represented here and 5 is here. 3 here, 5 here, 3 here, 5 here, 3 here, 5 here. But see how it's kind of interconnected? Each row contains the same thing. And you have 4 of those. Or I could break this up and say, okay, 4 times 3. 4 times 3. Which means I would take this picture and it would look a little bit more like this. 3, 3, 3, 3. Well, if I have all the 3's over here, then I need to do something with all those 5's. So that would look like 4 times 5. Where do those go? They end up in a block over here. So that would be like 5, 5, 5, and 5. 3's over here. Either way, you're going to get the same quantity, and I can prove that mathematically because 3 plus 5 is 8. 8 times 4 is 32. Okay, 32. Here, 4 times 3 is 12. 4 times 5 is 20. 12 plus 20 is 32. Either way you cut it, you get the same answer. Next, we are on to the associative property. Associative property. In addition and multiplication, you can group. Grouping. You can group a series of the numbers in any order and get the same answer. So basically, no matter which way you group it, you're going to get the same answer. So with the associative property of addition and multiplication, grouping doesn't matter in the sense that it doesn't change the answer. What does that look like for us? We could multiply 2 times 3 times 4, where we have an array that's a 2 by 3 array, and we have 4 of them. Two rows, 3 in each row, 4 of these blocks altogether, which is the same as having 2 3 by 4 blocks. So I could have a block of 12, because that's what 3 by 4 would be, and another block of 12. I could have 2 of these blocks, and its value would be equivalent to these blocks over here. So the grouping did not change the final outcome. That is what it's telling us. The grouping does not change the final outcome. Or we could try it with addition, where we have 6 plus 5 plus 1. So I can put together all my circles, 6 circles. I could add some triangles, 5 triangles, and an X. Well, if I put all that together, I'd still have the same group if I did there's a typo on this foldable here, equals 6 plus 5 plus 1. So you can put the 5 plus 1 over on this side instead. So the triangles could be with the X, or the triangles could be with the circles. Either way, you end up with the same type of group. Last is the identity property. We're going to discuss the identity property in a couple different ways. Numbers that keep their expressions the same. Multiplication, division, identity property. You can multiply 1 or divide by 1 to any number, and your number will stay the same. So 5 times 1 equals 5. Or 6 divided by 1 still equals 6. So that's the identity property of a multiplication and division. The additive and subtractive identity property, you can add 0 or subtract 0 to any number, and your number will stay the same. So I could do 5 take away 0, your number is still 5. 6 plus 0, your number is still 6. Nothing changes. Okay, so now you've concluded page 21. You can feel free to cut here and here to make it a flippable and paste it on here. That'll be your completed product here. I'm going to set that aside because I really want to focus in on page 22. There's a couple things we need to talk about on 22. The identity property of addition we just talked about. The identity property of addition is when you add 0 to anything and you still get the same thing. That can even work with negatives. So I could say negative 3 plus 0 you still have -3. That's the identity property of addition. The one we haven't discussed is the inverse property of addition. So let's write a definition for that. The sum of a number and its opposite equals what? Do you remember this? We studied this. The sum of a number and its opposite is 0. Fantabulous. For example, -2 plus +2, 0. Well done. Multiplication properties. Identity property of multiplication. We just discussed that one too. So an example of that is just 5 times 1. You still get 5. Identity. The zero product property we need to discuss. The product of a number and 0, the product of a number and 0 is what? Is 0. Anything times 0 is 0. So 5 times 0 is 0. -900 times 0 is still 0. If you've got 0 groups of something, you don't have anything. Property of -1. Last one for this page. The product of a number and -1 is the opposite of the number. The product of a number and -1, that means something times -1, is or results in the opposite number. Examples of that include, if we said 5 times -1, I would now be -5. If I'm -6 times -1, now I am +6. -1 multiplying by -1 turns it to its opposite. So 5 became -5, -6 became +6. You have successfully completed pages 21 and 22 for your interactive notebook. I will be back with further pages. Thank you for joining me.